Happy Friday, and we're looking at Module 4, Lesson 5. So today's aim is building off of yesterday. So we're going to look at the difference between what's called repeated multiplication and what we talked about, repeated addition. So in the do now, we just talked about how repeated addition is the same thing as multiplication. That's what we spent all of yesterday talking about. And so today, we're going to kind of take this a step further. We're going to say, what does repeated multiplication mean? So let's go ahead and look at this on the next page here. So page 2, daily lesson, opening discussion. All right, so I want you to think about these three right here. There's easier ways to write them, much easier ways. I don't want to just add all those numbers together. That'd take forever. There's a quicker way for me to think about it, and I can go back and access some facts in my head and figure it out. So I want you to, one, find the answer to these, and then describe a faster way than repeatedly adding those numbers. So go ahead, pause the video. You should take about 1 minute to find each of these three answers, and then tell me about the answer to number 1. So 1 minute on your own, pause, give it a shot. Okay, so we should be back here. And if I look at this, I have 1, 2, 3, 4, 5, 6, 7. I have 7 4s. That's the same thing as 4 times 7. So this whole thing, no matter what, is equal to 28. Let's look at the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 9, because we know repeatedly adding something is the same thing as multiplying it. So obviously that whole sequence of numbers, that whole expression is equal to 90. Last one, 1, 2, 3, 4, 5 10s. 5 times 10 or 10 times 5, doesn't matter. We still get 50 for our answer on that one. So describe a way to faster than repeatedly adding numbers. Well, you can multiply instead. You can multiply instead. You can specifically multiply the number you're adding by the number of times it's being added. So for example, back in this one, 10 times 5, because 10's being added, and how many times is it being added? 5 times. All right, so this one's different. Right here, this one is now different. We went from 10 added together 5 times to 10 multiplied 5 times. So let's think about two things. First, let's evaluate the expression, which means that's another word for find the answer, find the value, or calculate. And is there a faster way to think about this? Well, let's try it first. So I have 10 times 10 times 10 times 10 times 10. So let's multiply them in pairs. I know 10 times 10. 10 times 10 is always 100. And then 100 times 100, well, that's the same thing as, that's 10 to the power of 2 and 10 to the power of 2. So I have a total of 4 zeros I need to think about, or 4 powers of 10. So it would be 1 followed by 4 zeros. That's 10,000. 10,000. But we still have this fifth one left over. So I'm going to multiply this by 10, and that just adds another 0 on. So this whole thing equals 100,000. Now, if you're working on a calculator or typing this in, or if you want to write this whole thing out, it can be really annoying to have to write 10 times 10 times 10 times 10 times 10, and it can also be annoying to have to evaluate it and then find the value. So what we're going to talk about today is how we can take this right here, and we can say, hey, that's equal to 10 to the 5th power. That is called an exponent. That's what we're talking about today. So this is Introduction to Exponents. So we have two different forms we talk about when we think about exponents. We have what's called the exponential form, and we have what's called standard form. Not standard. Expanded form. So if you get your EX words mixed up there, I apologize. So again, we know exponential form, E-X-P-O-N-E-N-T-I-A-L form, and expanded form. Let's start with exponential form. I'm going to talk about two examples here. I'm going to do one with numbers and one with variables. So let's start with the one with numbers. Let's do 2 to the third power. So if you notice, my 2 is pretty big and my 3 is slightly smaller. And again, here's how I say this. I say this as 2 to the third power. This number right here is called my base, and this number right here is called my exponent. My exponent. And if I want to write this in expanded form, the base tells you what number you're multiplying. The exponent tells you how many times you're multiplying it. So down here in expanded form, 2 to the third power looks like this. It means 2 times 2 times 2. So I multiplied it. Multiply 3 times. Multiply 3 times. And how did I know that? Because this little number, my exponent, tells me how many times to multiply it. Tells me how many times. So what would this be equal to? Well, 2 times 2 is 4. 4 times 2 is 8. A lot of people say, oh, 2 to the third power, it's equal to 6. No, 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 no. It does not mean 2 times 3. It means 2 times itself 3 times. Let's try another one of numbers before we jump into the variable version. So we'll fit this in right here. Let's try 4 squared, or 4 to the second power. So first, what would this mean in expanded form? It would mean 4 times 4. My exponent tells me you need to multiply 4 by itself. I need 2 4s. This last time I was told 3, so it tells me 3 2s. So what does this equal? 4 times 4? Well, that's not 8. Don't make a silly mistake like we did right here and we crossed it off. 4 times 4, this is equal to 16. So let's think about this with variables. Let's say I gave you x to the 5th power. So again, how do I say that? Let's write it down. X to the 5th power. Nice. Now if I want to do x to the 5th power, we're going to do this now in what's called expanded form. Think about what expand means. Expand means to take something and to spread it out. So if I'm expanding x to the 5th, you can write it right down here if you have room. I'm going to write it right here. X to the 5th, I can say that's the same thing, and I know that doesn't look like a 5. Pretend that's a 5, not a 6. This would mean x times x times x, and those are dots in the middle of my x's, times x. How many times do I do it? I do it 5 times. Now, I don't know what x is equal to. So I can just say this. I can't say, oh, it equals 25. I can't say that. I don't know what x is until someone says, hey, x is worth 2. All I can say is x to the 5th. That's the same thing as x times itself 5 times. We need to do it 5 times. So that's all I know for right now. Let's try just a couple examples on your own, and then we're going to get together all at once. So let's go and see. Let's go and look at stretches 1 through 6 on the next page. So right here, I'm going to try this one with you, and I'm going to do this one with you, and then I want you to try the other 3 on your own. So this first one says in an exponential form. So first, I can see that there are a total of 1, 2, 3, 4, 5 times. So this is 5 multiplied 5 times. So this must be equal to 5 to the 5th power. Now here, those are both the same numbers. That's a 5. I know that my marker bled through. 5 to the 5th power. So again, that's 5 to the 5th power. So 5 was our base. It's the number we actually multiplied. This 5 represents the number of times we multiplied it. Let's try 3 together. 8 to the 3rd power. Well, the 8 means that's the number should be my base. 8 times itself 3 times. 8 times itself 3 times. Now, this does not say evaluate. It does not say do not evaluate. That means you don't have to find the answer here. All you have to do is give it to me in expanded form, just like we've done here. The 3 told us we need 3/8. All right, try 2, 4, and 5 now on your own. Pause the video, come back in about 30 or 40 seconds, and see if you got some of the same answers. And hopefully you're back after pausing your video. So I have 2. How many times do I have 2? Well, I have it 4 times, and I'm multiplying. That's key. If it were 2 plus 2 plus 2 plus 2, that would be very different. That would mean 4 times 2 Totally different. This means 4 times 2. That's not what we're talking about. We're talking about multiplication, though. So I'm going to say this is equal to 2 to the 4th power. 2 to the 4th power. So that's its exponential form. Let's keep it moving here. I have 10 to the 6th power. The 6 tells me how many 10s I need. So I need 10 of them. Not 10 of them, 6 of them. 4, 5, 6 10s. And it's an exponent, so that tells me I need to multiply all of these together. Multiply 10 times 10 times 10. Didn't tell me evaluate, so I can leave it right here as an answer. Evaluate should end with an E. Sorry about that. All right, last one, g to the 3rd, getting into variables now. So I have g to the 3rd. It looks like it might be really hard to see, so I'm going to say g to the 3rd. Well, let's see, g to the 3rd. G to the 3rd power, that doesn't mean, I need to think, does that mean add these together or multiply them? It's an exponent, so I need to think g plus g plus g. And I don't know what this equals until someone says, hey, g's worth 5, or hey, g's worth 1,000, or hey, g is worth 3.14. Whatever they tell me, I will go with, but for now, that's all I know.